Hi students, welcome to my channel Crack Physics with Anisha. Let's make physics concepts simple, fun and clear. Next questions are very simple. One by one we can answer. It is directly given in your textbook. What is dispersion of light? Dispersion of light is nothing else. It is a phenomenon of light in which the composite light like sunlight or white light. Why they are called as composite light? Because they have more than one color in it. Okay, so sunlight or white light will split into its component colors. Split into its component colors or constituent colors. It is called as dispersion of light. Very easy. Yes, sunlight or white light, when it passes through the prism, it will split into 7 different colors: violet, indigo, blue, green, yellow, orange, red, right? So that splitting of the light into its component color is called as dispersion. And second question, explain the condition under which dispersion happens. Okay, that is very important. Dispersion happens only because the cause or the condition is because we know that the speed of light is c equals 3 into 10 raised to 8 meter per second. That is in air or vacuum. Yes. So when light travels in air or vacuum, all the colors in the light will have the same speed. Okay. So in air or vacuum, light has same speed. All colors have same speed. But when it enters to a glass medium, all the colors have different speed. Okay, all colors have different speed. Now, why they are having different speed in a glass medium? Yes, so you know that the relation connecting the refractive index of the medium with the velocity of light. What is it? N is equal to C by V, where N is the refractive index of the medium, C is the velocity of light in air, and V is the velocity of light in medium, the glass. Okay, here it is the glass. Now, refractive index of air is 1. Okay, that is very easy. We know that. Now, the velocity of light depends on the wavelength of the light. There is a relation connecting velocity of light is equal to frequency into its wavelength. V equals F lambda. Now, we know each color has different wavelength, isn't it? Each color has different wavelength. If each color has different wavelength, all of them have different speed also, right? Yes. So, those colors with higher wavelength will have higher velocity. If they have higher velocity, from this relation we can say they will experience less resistive force in a medium. Isn't it? Less refractive index, less resistive force. Those colors will deviate less in a medium. For example, our red color. It has very high wavelength. That's why its velocity is also very high in a glass medium or any other medium other than air. So what happens? It will deviate less. It will very fastly it will reach the other side. Okay. But those colors with less wavelength, they will have less speed or velocity, and therefore we can say they have more refractive index. They experience more resistive force when they propagate in that particular medium. That's why they will deviate more. Or violet color, you remember? Yes. So the speed of light is same in air, but all colors have different speed in glass. The difference in the speed is due to difference in its wavelength. Due to the difference in the speed and wavelength, definitely the color will refract at different angles. So due to this different speed, the colors will refract at different angle. That's how the dispersion splitting up happens. Okay. Yes. Next part of the question, we can go to it. Give one reason that causes presbyopia. Now, presbyopia is a defect which happens during old age. When we grow older, this presbyopia is observed. Basically, this presbyopia is a combination of myopia and hypermetropia. You cannot see distant objects as well as nearby objects. So there you have to use a bifocal lens, a lens which is having both concave and convex lens. so that both type of images can be, like both type of objects can be, distant objects and nearby objects can be observed. Yes. Now what is the cause for presbyopia? Basically the cause is due to the weakening of our ciliary muscles. Okay, weakening of the ciliary muscles as well as the flexibility of our eyelids will be reduced. These are the two reasons. Flexibility of eyelids is reduced. So lens cannot focus the images properly on the retina, as well as ciliary muscles cannot help the lens to focus the images. Basically, the power of accommodation is reduced. So these are the two causes. Weakening of ciliary muscles and flexibility of eye lens is reduced. This is the cause for presbyopia. Moving to the next question. A student needs to make a 0.12 omega resistor. She has some copper wire of 0.80 millimeter diameter. Resistivity of the copper is given 1.8 into 10 raised to minus 8 omega meter. Determine the cross-sectional area of the wire and calculate the length of the wire required for the 0.12 omega resistor. So we can write down the data as given. She has to make a resistor of resistance 0.12 omega and copper wire is there. Its area of cross section is not given. We have to find it. We are provided with its diameter. Diameter is given as 0.8 millimeter. Now resistivity is also given 1.8 into 10 raised to minus 8 omega meter. How we can find the cross-sectional area? Now, in order to find the cross-sectional area, very simple. When we cut a conducting wire, we get its cross-section as a circle. So, cross-sectional area can be found using the equation of area of a circle, pi r square. Yes? Yes. Now, r radius is not given, but the diameter is given. So, first of all, you can find the radius. Radius is equal to diameter by 2. That is equal to 0.8 by 2. That is equal to 0.4 millimeter. Yes, now you can substitute here. Don't forget convert millimeter to meter when substituting it. So that is equal to pi into 0.4 millimeter converting to meter. We have to divide by 1000 whole square. That is equal to, you can substitute 3.14 into this one will be 0.16 divided by 10 cube whole square. It is 10 raised to 6. Simplify it, you will be getting the value 0.5028 into 10 raised to minus 6 meter square. You can just approximate the value to 5.03 into 10 raised to minus 7 meter square. That is fine, isn't it? Yes, this is the area of cross section of the given wire. Now we have to calculate the length of the wire so that we get 0.12 omega resistance. Now the equation connecting resistance, length, area of cross section and resistivity is R is equal to rho L by A. We have to find the length, right? So we are rewriting the equation as taking A to LHS, we get L is equal to AR by rho. That is also correct, isn't it? Length is equal to A into R divided by rho. That is equal to area of cross section. Just now we have found it is 5.03 into 10 raised to minus 7 into its resistance. It is given 0.12 omega divided by its resistivity is 1.8 into 10 raised to minus 8. As I always say, it's better don't touch the powers of 10. Just multiply the remaining part 5.03 into 0.12 divided by 1.8 into 10 raised to minus 7 into 10 raised to 8. Yes. So you will get the answer easily. That would be length is equal to 3.35 meter. Do the calculation part by yourself. This would be the final answer. Next question. Magnetic field lines are shown in the given diagram. A student makes a statement that the magnetic field at X is stronger than at Y. First part of the question, explain with reason if the student's claim is correct. Second question, also redraw the diagram and mark the direction of magnetic field lines. So the first question, the magnetic field at X is stronger than Y. Is that correct or not? When you observe the figure, you can see that the magnetic field strength, that means the magnetic field intensity is greater at poles, isn't it? What do you mean by magnetic field intensity? Magnetic field intensity is nothing else, or density means it is the number of field lines at that area. Is it closer to each other or are they away from each other? So magnetic field density is greater at poles. You can see that because they are closer to each other. Yes. So there they will experience stronger magnetic field, and at point Y we can see that the magnetic field lines are somewhat apart from each other, therefore it will experience lesser magnetic force. So we can say that the magnetic field is stronger at poles and lesser on the other area. So at point X it is stronger, so definitely the statement is correct, isn't it? Yes. So it is based on magnetic field density. Second question, redraw the diagram and mark the direction of magnetic field lines. So when you redraw the diagram, you have to draw the magnet, mark its north and south pole. When you draw the field lines, you should mark the direction. We know that the magnetic field direction is from north pole of the magnet to south pole of the magnet. It emerges from north pole and ends in south pole. So it will be like this, right? It's very easy. It starts from north pole, ends in south pole, and the direction of this magnetic field is found using compass needle. We can arrange the compass needle in the magnetic field, and then you can see the compass needle will be always pointing in north to south direction. So this is how you will get the direction of magnetic field lines. So if you draw more than one magnetic field line in each part, you will get it something like this, isn't it? Yes. North to south. You can draw few more magnetic field lines, which is showing that the field lines emerges out from here and ends in south pole. Yes, that is. So next question is a case-based question. A figure and a diagram is given there. The above image is that of a digital single lens reflector DSLR camera, which are used to take high resolution photographs by professional photographers. The second image of the above two is a schematic diagram of how an image is formed on the sensor of the camera, and based on your understandings of the lenses, answer the following questions. First question, what type of lens is used in the DSLR camera shown in the figure, and what type of image is formed on the sensor? So the figure is very clear. From the figure itself, we can see what type of lens is used. You can see the lens, it is bulged outwards, isn't it? Yes, its ends are thinner and center part is thicker. It is a convex lens. Convex lens, which is also called as a converging lens. It converges the light rays to a single point. So the first part of the question answer is convex lens. Now B part of the question, what type of image is formed on the sensor? Now we know that the lens is making an image of an object at infinity, and the image is formed on the other side of the lens, opposite side of the object. So from the figure itself, it is clear that it is creating an image. The nature of image they are asking, creating an image which is inverted as well as it is real, isn't it? It is real and inverted image. Why? Because it is called real because the image is formed on the real focus of the convex lens. It always creates real images. When the image is formed on the opposite side of the object, we call it as a real image. And from the figure itself, it is clear that it is an inverted image. If it is real image, definitely it will give an inverted image. The next part of the same question, section C, from that figure-based question. A photographer is using a DSLR camera with a lens of focal length f is equal to 50 mm to take a close-up photograph of a small object. The lens projects an image onto the camera sensor that is located 60 mm behind the lens. Calculate the object distance, that is the distance between the object and the lens. So we have to find out the object distance, basically u, right? Yes, what all data are given there? The focal length of the lens is given as 50 millimeter. Now from the figure we know that we are using a convex lens, and convex lens always gives a real focus, that is always to the right of the optic center, because the image is always formed, the image of an object at infinity is always formed to the right of the optic center. This is the focus, right? Yes. So it is a real focus. We get focal length as positive. Okay. So focal length is positive. Now, to take a closer photograph of the small object, he is focusing it. The lens projects an image onto the camera sensor, which is located 60 millimeter behind the lens. So the camera sensor is at what? 60 millimeter, isn't it? What does that say? Basically, the image is formed on the sensor. That means the image is formed at 60 millimeter. So we are provided with the image distance. So V is equal to 60 millimeter. Positive or negative? You have to apply the sign convention every time when we do the lens formula or mirror formula. Okay. So image is formed at the right side, isn't it, of the optic center. So we can take it as positive. It's given in the figure itself. So V equals positive 60 millimeter. We have to find U. You can use the lens formula. So according to lens formula, how we can write it? 1 by F is equal to 1 by V minus 1 by U. Now we have to find u. So 1 by u, take to the other side. Take 1 by f to the right hand side. So it will be 1 by v minus 1 by f. Now 1 by v means it is 1 by 60 millimeter minus 1 by 50 millimeter. You can cross multiply or take the LCM. So I'm cross multiplying here. 50 minus 60 divided by 60 into 50. Yes, that is equal to 50 minus 60 is minus 10 divided by 60 into 50. That means 6 into 5, it is 30 plus add 2 zeros. So 3000, that is 1 by 300. So minus 1 by 300 is 1 by u. So what will be u? 1 by u is equal to minus 1 by 300. You have to take the reciprocal to find u. U is equal to minus 300 meters. So you can see that the object distance obtained is in negative sign. That shows the object is kept towards the left of the optic center. That's why it is taken as negative. And that is 300 meters towards the left of the optic center, and that's the final answer. Thanks for watching. Subscribe for more videos, hit the bell icon and join our learning journey.